And here we're going to do Newton's third law. And Newton's third law is something that people are familiar with. They've heard it before, but I find it's hard for many people to actually grasp onto it and use it. So let's give it a shot. Let me know if it doesn't make sense. All right, now let's do Newton's third law. For every force, there is an equal and opposite force. Each force acts on a different object. Now this is just my phrasing. It's going to be different from the book. I don't require that you memorize the law exactly, but understand what it means and how to use it. So here's my typical example. I have a girl, and let's just say that maybe she was jumping on a trampoline or something, and she's just kind of free falling. We don't want to imagine parachutes or airplanes or even just standing on the floor. So imagine her mid-jump in a trampoline. Now we know that gravity is going to pull her down with a certain amount, and I picked 800 newtons. So Earth is going to pull her down with 800 newtons with gravity, or her weight. But what Newton's third law tells us is that this force has a paired force, and that has to be equal and opposite and act on a different object. So the paired force here is that the girl is actually pulling the Earth up with the same amount, 800 newtons. Another example could be the chair is holding you up with 800 newtons. So that means you are pushing into the chair with 800 newtons. And sometimes it's hard to find out exactly where that second force is acting, or it can get kind of confusing. So here's my hint, is notice the two objects, Earth and the girl. And for one of those forces, it's the Earth pulling on her. For that other force, you just flip those objects. It's her pulling on the Earth. If I press down on the desk with 10 newtons, my hand is pressing on the desk downwards with 10 newtons. So what is the desk doing back to me? The desk is pressing up on my hand with the same amount. So sometimes I've gotten the question then of, if the forces are equal, why doesn't the Earth also come up to meet the girl? Like usually we just imagine the person falling to the Earth. We don't imagine the Earth falling upwards to meet them halfway. The forces are equal, but the accelerations are not equal. Since the Earth has a lot more mass, it would need a huge amount of force in order to get the Earth to actually fall up to meet her. So perhaps for fun, I've calculated the girl's acceleration due to 800 newtons of force and the Earth's acceleration due to 800 newtons of force. So the unbalanced force divided by the girl's mass would lead us to a value of g, 9.80 meters per second squared. So the girl will accelerate. She will noticeably fall downwards. Now the Earth will have an acceleration due to the 800 newtons upwards divided by the Earth's mass. And the Earth's mass is huge, and it's in the denominator, so that makes the acceleration tiny. So the Earth would technically have a teeny tiny acceleration upwards, but this number is so small we can't even measure it. We just say 0.